So, how do we actually talk about when and where things happen? You know, it seems like such a simple question, doesn't it? It's something we figure out every single day. But as we're about to see, the way physics answers this question, well, it tells us something really, really profound about the universe itself.
I mean, just think about it for a second. You want to meet a friend for coffee. You have to nail down two things perfectly, the place and the time. It feels totally trivial, but getting this right is this fundamental challenge, not just for our coffee dates, but for describing, well, everything.
In physics, any specific happening, whether it's our coffee meeting or a star exploding millions of light years away, has a name. It's called an event. And to be there for it, you've got to be in the right place at the right time. So, how do we come up with a universal system to describe that place and that time so that anyone, anywhere knows exactly what we're talking about?
Well, the solution we humans came up with is the origin. And that's just a fancy word for an agreed-upon starting point. You can think of it like a universal "you are here" sign for both space and time. It's the one spot we all agree on, so we can measure everything else from there.
Right, so once everybody agrees on that origin, the rest is actually pretty straightforward. We can say an event is, 5 miles north of the town square, happening at 3 p.m. The distance, the direction, the time, it's all measured relative to that shared starting point.
So, that's our everyday solution. But how do physicists make it official? Well, they've created this super precise address system that can pinpoint any event anywhere in the entire universe.
So how many pieces of information does it take to absolutely perfectly nail down an event? Turns out, the answer is always 4. Not 3, not 5. You need exactly 4 specific measurements. We call them event coordinates, and they're like a unique address in space-time.
So what are these 4 coordinates? Okay, first the obvious one. Time. When is it happening? Then you need 3 for the location. Think of it like this. First, how far away is it? That's your distance. Next, which way do you have to turn? Side to side. That's the azimuth, kind of like pointing east or west on a compass. And finally, how high up in the sky do you need to look? That's your altitude. Those 4 together, they give any event its own unique cosmic address. Now, those 3 location coordinates, the distance and the 2 angles, we lump those together and call them the event's position. It's a simple little distinction, but it's super important. An event is always defined by its time and its position. And this brings us to a huge concept in physics. A quantity-like position, which has both a size, or a magnitude, like how far away it is, and a specific direction, is called a vector. We're going to see vectors pop up all over the place, but position is our very first and maybe most important example.
Okay, so let's just pause for a second. It really seems like this whole origin idea, this agreed-upon starting point, is the absolute foundation for how we describe reality. I mean, without it, we can't define an event's coordinates. It seems completely essential, right?
Well, here's where things get really weird. We might need an origin to talk to each other, but does the universe actually need one? Does reality itself have some kind of special, built-in starting point?
Get ready for a bit of a mind bender here, because the answer, according to all the scientific evidence we've ever gathered, is a huge, resounding no. The universe, as it turns out, gets along perfectly fine without any special origin point at all.
And here it is, the shocking truth, stated plain and simple. The laws of nature do not depend on our choice of origin. Just let that sink in. The fundamental rules of physics, gravity, electromagnetism, the whole shebang, they work the exact same way no matter where or when you decide to start measuring from. The universe just doesn't have a favorite spot. The laws of physics are the same right here as they are in a galaxy a billion light years away. Nature is completely, totally indifferent to the imaginary starting lines that we draw.
So if the universe doesn't care about the origin, what does it care about? It cares about this: relative coordinates. It's not the distance from an event to some imaginary point that matters. What's real, what's fundamental is the distance, the direction, and the time between 2 actual events. So this leaves us with this fascinating puzzle, doesn't it? We seem to need an origin to communicate with each other, but the laws of nature absolutely do not. So how do we square these 2 totally different perspectives?
And here's the 2 viewpoints right next to each other. For us, for human communication, we absolutely need that shared origin to create a grid so we can talk to each other. But for the universe, for the laws of nature themselves, only the relationship between events matters. The origin is just a convenient tool that we invented.
So here's the big takeaway.
The origin points we use are basically just a map we draw on top of reality to help us get around. But the universe itself, the actual territory, it runs purely on the relationships and the intervals between events. And this isn't just some fun philosophical point. This one idea is the bedrock for some of the biggest theories in all of physics, including Einstein's relativity.
And that's really what I want to leave you with. If the fundamental laws of nature are truly the same everywhere and at all times, with no special starting point, what does that imply about our own significance? It kind of suggests there is no center of the universe, which also means that, in a way, everywhere is.